Hello friends, welcome to my channel Study Corner. So today we will discuss about the magnetic effect of the electric current. Hans Christian Ørsted in 1820 he accidentally discovered that a compass needle got deflected when an electric current passed through a metallic wire placed nearby. Through this observation, Ørsted showed that electricity and the magnetism were related phenomena. As we can see in the figure, when the current is flow, the needle get deflected. As the current is flow, the needle get deflected. Some case of the two magnets, if both has a north pole and south pole and north pole, then they will attract. And the second case is if both the magnet has a north pole and both the magnet has a south pole, then it repels together. Now, magnetic field and the field lines. So, drawing the magnetic field lines with the help of a compass needle. So, this kind of figure we get. So, next. The compass needle is in fact a small bar magnet. Compass needle is nothing but a small bar magnet. The end point towards the north pole is called the north seeking or the north pole, and the other end of the points toward the south is called the south seeking or a south pole. As we see, this point is called the north seeking or the north pole, and the other one is called the south seeking or the south pole. So now we will discuss about some properties. The magnetic field is a quantity that has both the direction and the magnitude. Again, the magnetic field is a quantity that has both the direction and the magnitude. The other one is inside the magnet, the direction of the field line is from its south pole to its north pole. As we see, from inside the magnet, the direction of the field lines from its south pole to its north pole. It is always from south to north. Now, the magnetic field lines are closed curve. It is always in the closed curve path. The relative strength of the magnetic field is shown by the degree of closeness of the field lines. Now, the direction of the magnetic field is taken to be the direction in which a north pole of the compass needle moves inside it. Therefore, it is taken by convention that the field lines emerge from the north pole and merge at the south pole. ચુંબકીય ક્ષેત્રની દિશા એ દિશામાં લેવામાં આવે છે કે જે દિશામાં હોકાયંત્રની સોયનો ઉત્તર ધ્રુવ ક્ષેત્રમાં ગતિ કરે. તેથી રૈવાજિક રીતે ક્ષેત્રરેખાઓ ઉત્તર ધ્રુવથી નીકળી અને દક્ષિણ ધ્રુવમાં દાખલ થાય તેમ લેવામાં આવે છે. નાવ ધ આયરન ફિલિંગ્સ અરેન્જ ધેમસેલ્સ ઇન અ પેટર્ન એઝ શોન. આપણે ફિગરમાં જોઈ શકીએ છીએ કે નોર્થ અને સાઉથ પોલ મેગ્નેટ બતાવેલું છે, તેમાં ક્ષેત્રરેખાઓ જે મેગ્નેટિક ફિલ્ડ લાઇન્સ છે એ કર્વડ પાથ રચે છે. The region surrounding a magnet in which the force of the magnet can be detected is said to have a magnetic field. The lines along which the iron filling aligns themselves represent the magnetic field lines. Which means કે જ્યાં ચુંબકની આસપાસનો વિસ્તાર કે જેમાં ચુંબકના બળની અસર અનુભવાય છે તેને ચુંબકીય ક્ષેત્ર કહેવામાં આવે છે, અને લોખંડનો ભૂકો જે રેખાઓ પર ગોઠવાય છે તેને ચુંબકીય ક્ષેત્ર રેખાઓ કહેવામાં આવે છે. જે લાઇન્સ આપણે જોઈ શકીએ છીએ એને ચુંબકીય ક્ષેત્ર રેખાઓ કહેવામાં આવે છે. The other property is no two field lines are found to cross each other. બેઉ field lines છે એ બેઉ એકબીજાને પરસ્પર ક્યારેય છેદતી નથી. We have see the two case, the magnetic field lines not intersecting, and the other case is magnetic field lines is intersecting. So it is first case and it is second case. So as we see, if they intersect, they did, it would means that at the point to intersection the compass needle would point towards the two direction, which is not possible. જો બેઉ મેગ્નેટિક ફિલ્ડ લાઇન્સ પરસ્પર એકબીજાને છેદે તો છેદ બિંદુ પર તે બે ડાયરેક્શન્સ બતાવે છે, જે વાસ્તવિકતા માટે પોસિબલ નથી. માટે no two field lines are found to cross each other. Magnetic field due to a current through a straight conductor. So first of all, what is straight conductor? Straight conductor is a wire having a magnetic field center on it. Any straight line which is act as a wire having a magnetic field center on it. Now first consider the pattern of the magnetic field around a straight conductor carrying the current. So consider this figure particularly. First consider the pattern of the magnetic, which is this is the pattern, magnetic field around a straight conductor, which is carrying the current. If the current is increased, if current is increased, the deflection, if current is increased, the deflection is also increased. It indicates that the magnitude of the magnetic field produced at a given point increased as the current through the wire increased, which shows તારમાંથી વહેતા વિદ્યુત પ્રવાહના મૂલ્યમાં વધારો કરતા તારમાંથી વહેતા વિદ્યુત પ્રવાહના મૂલ્યમાં આપેલ બિંદુ પાસે ઉત્પન્ન થતા ચુંબકીય ક્ષેત્રના માનમાં પણ વધારો થાય છે, which is also increased. Now place a compass at a farther point, any point. If we take here any point, then at that point from the conducting wire, what change do you observe? We see the deflection in the needle is decreased. Thus, the magnetic field produced by a given current, in the conductor decrease as the distance from it increases. It is decreased as the distance from it increases. It can be noticed that the concentric circles representing the magnetic field around a current carrying straight wire become a larger and larger as we move away from it. વિદ્યુત પ્રવાહ ધારિત સુરેખ તારથી દૂર જતા જઈએ તેમ આજુબાજુ ઉદ્ભવતા જે સર્કલના આજુબાજુ ઉદ્ભવતા ચુંબકીય ક્ષેત્રને દર્શાવે છે, તે કન્સેન્ટ્રિક સર્કલ્સ મોટા અને મોટા થતા જાય છે. Right hand thumb rule. Imagine that you are holding a current carrying straight conductor in your right hand. First of all, imagine that you're holding a current carrying straight conductor, any current carrying straight conductor in your right hand, which is current carrying. Now such that the thumbs points toward the direction of the current, and then your fingers will wrap around the conductor in the direction of the field lines of the magnetic field. Suppose this is the current carrying straight conductor, and this is your finger which is wrapped around the conductor, as we can see in the figure. The called right hand rule. Many students make a mistake by taking the left hand to find the direction of the magnetic field in the examination, but here it is clearly mentioned that it is a right hand rule. Thank you.